Okay, we're going to do some work on composite shapes. Now, a composite shape is, well, if we deconstruct the word composite, it means it's composed of more than one thing. So a composite shape is a shape that's composed of two separate shapes. For example, let's say we had a composite shape which was a cone and a hemisphere. Okay, now what we're going to say is that the height of the full shape is 16 centimetres and the diameter of this circular part of the shape down here is 12 centimetres, and our challenge is to find the volume of that shape. Okay, so our first move is to break the shape into two bits, so let's call that part 1 and that's part 2. Okay, now we can see that volume 1 is a cone, so that's 1/3 pi r squared h. Well, remember that r is the radius and h is the height. Okay, so we need to find the radius of the circular part of the cone and the height of the cone. Okay, so we can see that the radius is given by this bit here. Okay, well, we know that the diameter from here to here is 12 centimetres. So that means that the radius there must be 6 centimetres. Now it's tempting at that point to say the height of the cone is 16. The height of the cone is not 16, the height of the full shape is 16, but the full shape includes both the cone and the hemisphere. The height of the cone doesn't start from there down to there, it starts from there and finishes here. Okay, so the height of the cone is given between here and here. Now we can easily work that out. We know that the radius of the hemisphere is 6 centimetres, so if it's 6 centimetres that way, it's also 6 centimetres that way. So that means between here and here, that's 6 centimetres, which tells me that the height of the cone is actually 10 centimetres. So it's 1/3 of pi times the radius squared, 6 squared, multiplied by the height of the cone, which is 10, and then I can put all that into the calculator. Okay, to one decimal place, then that will give me 377.0 cubic centimetres. Okay, so let's now go after the volume of this bit. Well, we can see that this bit that looks like a cereal bowl, well, that's half a sphere, it's a hemisphere. So remember that the volume of a sphere is 4/3 pi r cubed. So a hemisphere then would be half of that, 2/3 pi r cubed. Okay, so that's 2/3 of pi times the radius cubed, the radius being 6 times 6 cubed. Enter that into the calculator. And to one decimal place, that is 452.4 cubic centimetres. Okay, TV for total volume, add these both together, 377.0 plus 452.4, and that will give me 7 plus 2 is 9 there, 7 plus 5 is 12, 2 down, carry 1, 4, 3, and 1 is 8, 829.4 cubic centimetres. Okay, let's now just describe how we get that answer again. Now, the first thing is we've got a composite shape, so it's made up of more than one shape. It's got a conical shape, a cone, and a hemisphere. So we've called the conical bit the cone, volume 1, and the hemisphere bit, we've called that volume 2. Okay, so volume 1, first thing is to get the formula, and that's 1/3 pi r squared h. So the radius is the first thing that we're looking for. Well, we can see that the diameter of the cone was given by 12, so its radius must be 6. Okay, the next bit is to figure out the height of the cone. Now, the height of the cone could be tempted to say at that point it's 16, but that's the height of the full shape. The height of the cone goes from here to here, not from here to here. So we need to eliminate this bit here. Well, if that was 6, and that's the radius, that's also the radius, that's also 6. So I need to take that 6 away from 16 to leave me with 10 for the height of the cone. Throw that in the calculator to get 377.0. Okay, then we know that the hemisphere is given by 2/3 pi r cubed, since the sphere is 4/3 pi r cubed, so that's half a sphere. So it's 2/3 times pi times the radius, 6 cubed. Put that into the calculator. We've got the two different volumes. We add them together to get 129.4 cubic centimetres. Okay, let's try an example 2. Okay, so we've got a shape with a hemisphere up top and a cylindrical part here. Okay, we're also told that the height of the full shape is 20 centimetres and that the radius of the circular part of the cylinder there is 6 centimetres. Okay, so let's call that volume 1 and volume 2. Let's go after volume 2 first of all. Okay, so volume of a cylinder is one that won't be given to you in your formula sheet. In the formula sheet, you'll be given the volume of a cone, a sphere and a square-based pyramid, but not a cylinder. Now, the volume of a cylinder is given by the area of the circle multiplied by the height of the shape. So the area of the circle is pi r squared, and that's multiplied by the height of the shape. Okay, so it's pi times, well, the radius is clearly 6 squared multiplied by the height. Now again, it could be tempting to put down the height as 20 there, but that's not the height of the cone, that's not the height of the cylinder rather, that is the height of the full shape. Now to get the height of the cylinder only, we need to find this height here. Well, we know that the radius there is given by 6. Well, if it's 6 there, it's also 6 there. So that's definitely 6 centimetres. Now this 6 centimetres off the 20 centimetres will now give me the height of the cylinder, which is 14 centimetres. Okay, so it's pi times 6 squared times 14. Enter that into the calculator. And that will give me 1,583.4 cubic centimetres, final answer. Okay, we now need to find the volume of the hemisphere. So remember, a sphere is 4/3 pi r cubed, so the hemisphere is 2/3 pi r cubed, which is half of the 4/3 pi r cubed. Okay, so that's 2/3 multiplied by pi multiplied by the radius 6 cubed. Okay, and into the calculator. And that'll give me 452.4 cubic centimetres. To get the total volume, then add these both together, 1,583.4 plus 452.4. Okay, so 4 plus 4 is 8, line up a decimal point, 3 plus 2 is 5, 8 plus 5 is 13, 3 down carry 1, 5 plus 4 plus 1 is 10, 0 down carry 1, and that is 2,035.8 cubic centimetres. Okay, so let's just describe where that came from again. So again, it was a composite shape. We split it into two separate shapes, the first being the hemisphere and the second being the cylinder. Okay, so the volume of a cylinder is the area of the circle multiplied with the height of the shape, so that's pi r squared times height. So the radius of the cylinder is 6 pi times 6 squared multiplied by the height of the cylinder. The height of the cylinder is not 20. The height of the cylinder is between here and here. The height of the full shape is 20. So I need to subtract the hemisphere part off. Well, I know that the radius there is 6, so 6 there, and the height is also 6. So 6 off the 20 will give me 14 for the height. Into the calculator to get 1583.4. Okay, then a hemisphere is half a sphere. A sphere is 4/3 pi r cubed, so the hemisphere is 2/3 pi r cubed. 2/3 times pi times 6 cubed, which will give me that. Add these two together to get 2,035.8 cubic centimetres, final answer.